Today, we're going to tackle quadratic equations, focusing on a specific example that requires careful manipulation before we can solve it. Here's our quadratic equation. X times open parentheses, 2x plus 3 close parentheses, minus 6 equals 0. This equation isn't immediately solvable in its current form. Notice the structure of this equation. We have a term in parentheses being multiplied by x, which means we'll need to use the distributive property to expand it. Before we can apply any quadratic formula or factoring techniques, we need to convert this to standard form. Ax squared plus bx plus c equals 0. The standard form allows us to identify the coefficients we'll need for solving. Our first step is to expand the left side of the equation by multiplying x through the parentheses. This will give us a polynomial in descending order of powers, making it easier to identify our coefficients a, b, and c. When we expand x times 2x plus 3, we'll multiply x by each term inside the parentheses. This gives us x times 2x, which is 2x squared, plus x times 3, which is 3x. This is a crucial algebraic skill for solving many types of equations. Once we've expanded the expression, we'll have all terms in polynomial form, which will allow us to reorganize them into the standard form and proceed with solving using either the quadratic formula or factoring, depending on which is more appropriate. Understanding this initial step of expansion is essential. Without properly converting to standard form, we can't accurately identify the coefficients needed for solving quadratic equations. In this problem, we need to expand the quadratic expression x times the quantity 2x plus 3 minus 6 equals 0. This will allow us to convert it into the standard form of a quadratic equation. Let's move our original equation to the top, so we have room to work through the expansion step by step. To expand this expression, we need to apply the distributive property. This means multiplying x by each term inside the parentheses separately. We'll rewrite it as x times 2x plus x times 3 minus 6 equals 0. Let's look at each multiplication separately. First, we have x multiplying 2x. Remember that when you multiply variables, you add their exponents. Since x has an implied exponent of 1, and 2x also has an x with an implied exponent of 1, we'll get x squared in our result. For the first term, x times 2x, we multiply the coefficients 1 and 2, giving us 2. Then for the variables, x times x gives us x squared, so x times 2x equals 2x squared. For the second term, we have x times 3. Since 3 is just a constant, we multiply it by x to get 3x. There's no exponent to worry about here, since we're just multiplying a variable by a number. Now we can substitute these results back into our equation. The first term becomes 2x squared, the second term becomes 3x, and we still have minus 6 equals 0. We've now written our equation in the standard form of a quadratic equation. Ax squared plus bx plus c equals 0. In this case, a equals 2, b equals 3, and c equals negative 6. This form is particularly useful because it allows us to apply various methods for solving quadratic equations, such as factoring, completing the square, or using the quadratic formula. Notice how expanding the original expression has given us a clearer view of this quadratic equation. We can now identify the coefficient of each term, which is essential for solving the equation. Now that we've identified our values for the quadratic formula, let's solve for x in our equation, x times open parentheses 2x plus 3, close parentheses minus 6 equals 0. We've already expanded the equation and determined that a equals 2, b equals 3, and c equals negative 6. Substituting these values into the quadratic formula, we get x equals negative 3 plus or minus the square root of 57, all divided by 2 times 2. Let's simplify the denominator. We have 2 times 2 in the denominator, which equals 4. This gives us x equals negative 3 plus or minus the square root of 57, all divided by 4. The plus or minus symbol tells us that we have two distinct solutions to our quadratic equation. Let's separate them and call them x sub 1 and x sub 2. For x sub 1, we'll use the plus sign, and for x sub 2, we'll use the minus sign. To find the decimal values of our solutions, we first need to calculate the square root of 57. Using a calculator, we find that the square root of 57 is approximately 7.55. This irrational number will help us find the approximate decimal values of our solutions. Now we can substitute this value into our two solution formulas and calculate the results. For our first solution x sub 1, we replace the square root of 57 with 7.55, giving us negative 3 plus 7.55 in the numerator. When we add these terms, we get 4.55. Then we divide 4.55 by 4, which gives us approximately 1.14. So our first solution is x sub 1 approximately equals 1.14. For our second solution, x sub 2, we use the minus sign, giving us negative 3 minus 7.55 in the numerator. This equals negative 10.55. Dividing negative 10.55 by 4 gives us approximately negative 2.64. So our second solution is x sub 2 approximately equals negative 2.64. These two values, 1.14 and negative 2.64, are the solutions to our original quadratic equation. If we were to substitute either of these values back into x times open parentheses 2x plus 3 close parentheses minus 6 equals 0, the equation would be satisfied. For completeness, let's display both the exact form of our solutions with the square root and their decimal approximations side by side. Here we have our complete solution set. The exact solutions are x sub 1 equals negative 3 plus the square root of 57, all divided by 4, which is approximately 1.14, and x sub 2 equals negative 3 minus the square root of 57, all divided by 4, which is approximately negative 2.64. It's always good practice to verify these solutions by substituting them back into the original equation. You would find that both x equals 1.14 and x equals negative 2.64 satisfy our original equation, x times open parentheses 2x plus 3 close parentheses minus 6 equals 0. Now that we've found our solutions using the quadratic formula, let's verify that one of them actually works by substituting it back into the original equation. To verify this solution, we'll substitute x equals 1.14 into our original equation, x times quantity 2x plus 3 minus 6 equals 0, and check if the left side equals the right side. This process is crucial because it confirms our algebraic work is correct. For our first step, we substitute 1.14 for every x in the equation. Now let's calculate what's inside the parentheses. We need to multiply 2 by 1.14, which gives us 2.28. For our second step, we simplify inside the parentheses by adding 2.28 and 3. This gives us 5.28. Now for our third step, we multiply what's outside the parentheses with what's inside. When we multiply 1.14 by 5.28, we get 6.02. For our fourth step, we complete the left side of the equation by subtracting 6 from 6.02, which gives us 0.02. We get 0.02, which is extremely close to 0. The small difference is due to rounding in our calculations, since we're using an approximate value of 1.14 rather than the exact value, which would involve a square root. This confirms that x equals 1.14 is indeed a solution to our original equation. Let's review the key steps we took to solve this quadratic equation from the beginning. First, we expanded the original expression by distributing x to get a standard form quadratic equation. This transformed x times quantity 2x plus 3 minus 6 equals 0 into 2x squared plus 3x minus 6 equals 0. Next, we identified the coefficients in our standard form equation. We found that a equals 2, which is the coefficient of x squared, b equals 3, which is the coefficient of x, and c equals negative 6, which is the constant term. Then we applied the quadratic formula, which states that x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This formula always gives us the solutions to any quadratic equation in standard form. After substituting our values into the formula, we simplified to get x equals negative 3 plus or minus the square root of 57, all divided by 4. The square root of 57 is approximately 7.55. Finally, we calculated both solutions by evaluating the formula with both the plus and minus operations. This gave us our two solutions, x approximately equals 1.14 and x approximately equals negative 2.64. Our final solutions are x approximately equals 1.14 and x approximately equals negative 2.64. These are the two values of x that make the original equation true. We've verified the first solution, and you could verify the second solution using the same substitution process. Both these values represent the exact points where the quadratic function crosses the x-axis.